Hi. Today we're going to be going over quadratics and the vertex. Now, the vertex of a quadratic is part of a special trick that you can use when graphing quadratics to make your process of graphing much easier. It also shows up a lot in worksheets and problems in math class that can be kind of tricky if you're not really used to the idea of a vertex and used to figuring out and handling quadratics. So that's what we're going to do in this video. We're going to go over what the vertex is, why we use it in math, and why it can be helpful for graphing quadratics, and then go over some examples of it. So here we have three forms of the same quadratic. They're the exact same. If I were to take these out and I were to do the multiplication here, I'd get this one. If I were to expand this out and do the simplification here, I would get this one. And so we have three different types of forms, and two of them are kind of familiar, right? This one is just the standard form of a quadratic, right? We write our different terms in order from greatest degree to least degree. This one is our factored form, you might say, split up into two factors. And this one here, what we're going to talk about today, is the vertex form. And I'll show you why the vertex form is really useful. So let's imagine that we were told to graph this quadratic. And we did the factoring, the simplification, and we got out and we got this. Right? So we factored it down to this. X minus 5 times x minus 1. Now, we know that we want to know the x-intercepts, the points at which this graph touches the x-axis to help us graph this curve, right? So we have our factored form equals 0, right? To find the points where y is 0 for these x values. That means x minus 5 equals 0 and x minus 1 equals 0. Or x is equal to 0, so y is equal to 0 at x equals 1 and 5. So if we were to graph this, knowing of course that the curve is positive because that's a positive x value, x squared term, we'd expect to have something like this. And that looks all well and good. We were able to get a quick estimate of our graph, but we weren't actually able to know for certain what the vertex was, or the point, the lowest possible point of that quadratic, the point where both curving sides come and meet a single point. And that's where the vertex form really shines. Because oftentimes you'll get problems that say, what's the vertex of this equation? Or what's the axis of symmetry, which is just the x value of the vertex. And that's where the vertex form is really handy. So let's say we were just given this form and we told it was the vertex. No context whatsoever about what the vertex is. Let's just go ahead and graph it and see what we get and see how we graph it. Right? So the first thing I notice is that this term right here, this x minus 3 squared, is always going to not be negative. It's never going to be negative. Because even if this x minus 3 was negative, we're squaring it. So we're going to get a positive value. The smallest it can be is 0, right? Once we can say that this is going to be greater than or equal to 0. So let's say we're graphing this and I say, okay, well, squared, that means we're going to have like an x squared term, so it's probably a quadratic. I say, well, I'm going to start up by trying to find the lowest possible point, right? That's going to be where this whole thing is 0. And to make that 0, I'm going to have x equal 3. Because when x equals 3, I'll have 3 minus 3, that's 0, squared is 0. But this whole y value then will be 0 minus 4, or negative 4. So the lowest point would be 3, negative 4. So I'll go ahead and graph that. It's always a good idea to label your axes. Okay, and now we're here. And we can probably say, okay, so I know it's going upwards, so I've got this and I've got this. So yeah, I have the general form of my quadratic down. And here we notice, well, this point here, the vertex, is actually the point we graphed, 3, negative 4. And here, that's where the vertex is really, really helpful for just the vertex form, for instantly spotting that one point that you can then use to instantly plot your quadratic and then do the estimation of where different intersections are going to be. And of course, we actually did a pretty good job of matching the original quadratic that we graphed, right? It has roots at 1, 5. Of course, if we plotted more points, we could get it more accurately. But just given this form, we were able to get 1 point down and then graph the whole thing with these. So the general form of a vertex, right, is if you have something like, I don't know, y times, I'm going to just call it a number z, right? In this case, it was 1, but if you have something like, 3x squared, you want to be sure to factor out that 3, times x minus a squared plus b, right? And your vertex, just given that equation, you know the vertex. The vertex of the resulting parabola when you graph it is always going to be a, b, where a is the x value and b is the y value, right? Notice I didn't say negative a, right? If I have a term like x minus a, right, then my a in my graph is going to be positive. It's just like we had x minus 3. Right? That didn't mean the vertex had an x value of negative 3. It had an x value of positive 3. However, if this was x plus 3, it would be x minus 3, right? Basically, the sign in here is the opposite or the inverse of the sign of the corresponding vertex coordinate. And that's graphing with the vertex. It's really simple, it's really easy, and it's really, really nice to do. But let's say, you're asked to write a quadratic in vertex form. You're asked to write that. And then that's where things can get a little tricky. Now, the important thing to remember here is that when we're graphing, we don't really have to worry too much with the inner workings of the algebra. But when we're asked to write equations in different forms, we do. And it is important that we think about the algebra that we're doing. Because when we want to transform a standard quadratic into a vector form, you have to think about the form of that vertex form, right? It always has a squared term and a number, right? So here, to transform a standard form into a vector, a vertex, we're going to do what's called the difference. We're going to do what's called the completing the square, where we transform this equation into a term with a square, and a term without the square. Basically, we're trying to make a square out of this equation, right? Make an expression, make a quadratic that can simplify down to x minus something or x plus something squared, and then have another term so it isn't actually that value. And I'll show you what I mean, right? So y equals x squared minus 6x plus 5, right? Nice. And I'm going to use what I call the magic rule, which is b over 2a, right? The form of a square, right? If you have, let's say, x minus b squared, it's going to be x minus 2b plus b squared in its fully expanded version, right? So x squared minus, all right. So in this case, that negative 6 is our negative 2b. So our b is going to be 3. So we know we're going to have x minus 3 squared then in our vertex form. But we're not done. This x minus 3 squared, we're going to expand this all out. Now x minus 3 squared is x squared minus 6x plus 9. We don't have plus 9 in our original equation. So we actually have to subtract 4 from 9 to get 5, because in our original term we do have 5. So it's really about focusing on these terms, saying, okay, what do I have to add to make this a perfect square? In this case, I have to add 9. And then, okay, what do I have to make? Basically, I have to make this be a 9. But then I'm going to I need to add a 4 here, because I can make this a 9. Then I need to make sure to subtract that 4, because if I do something on one side that changes the value, I have to do it on another side. So if I just left it as plus 4, then I have to do y plus 4. That's what I have to do on one side, I have to do on both sides. But I don't have to do that if I do 4 minus 4, because it simplifies that to 0. So that means that I can have x squared minus 6x plus 9 minus 4, which turns into x minus 3 squared minus 4, which is indeed the vertex 4. And so by completing the square, I've transferred my standard form into vertex form, and now I can graph it really easy. If this was confusing for you, I have a video on completing the square. Just check it out on my YouTube channel. But that's all. I hope you have a great day, and I hope you do amazing.